Welcome to Spatial Patterns of Mineral Deposits in the Broken Hill region, New South Wales, Australia. This presentation has been prepared because it is part of the research with the title The Spatial and Temporal Distribution of the Metal Mineralization in Eastern Australia and the relationship of the observed patterns to giant ore deposits. New South Wales. The Broken Hill deposit is located in the far western part of New South Wales. First, let's look at the high temperature type deposits. The most important of which is the Broken Hill type, consisting of stratiform disseminations or pods of galena, sphalerite, quartz, granite lode. The giant Broken Hill deposit consists of three contiguous ore bodies containing more than 200 million tons of high-grade lead, silver, zinc ore. There are 525 minor Broken Hill type deposits in the region, and each contain only a few thousand tons of ore. The giant and minor Broken Hill deposits. Pattern recognition by clustering the Broken Hill type deposits. The autoclust algorithm allows that clustering to take place through automatically extracting boundaries based on Voronoi and Delaunay diagrams, also known as tessellations. Parameters are not specified by users in the automatic clustering. All clustering operations takes place on the Delaunay diagram, where data points become vertices and edges connect pairs of points to model spatial proximity. The Delaunay diagram with Broken Hill type deposits. The Voronoi tessellation without deposits. Voronoi tessellation with clusters. Voronoi tessellation with boundaries. Voronoi tessellation and polygonization. Polygonization. Polygonization with giant deposits. Polygonization, giant deposits, and radial trends. The lower temperature type deposits. Even though 10 different types of deposits have been recognized, the first three, Thackeringia, Mount Rope, Gold Vein, are adequate to show the patterning in the region. The Thackeringia type deposits, consisting of narrow veins or chutes and pods in veins in fault zones of argentiferous galena bearing siderite quartz veins. The Thackeringia type with the giant Broken Hill deposits. The Mount Rope type, which consists of narrow, long, tabular bodies of galena, sphalerite, chalcopyrite, plus or minus gold, bearing quartz fluorite veins, where the veins transgress layers in the host rock. Mount Rope type and the giant Broken Hill deposits. Gold vein type, consisting of pyritic or cupriferous quartz veins with gold. Gold vein type and giant Broken Hill deposits. The high temperature giant Broken Hill type and the three lower temperature type deposits are shown in the following slide. The paleothermal thermometer in the Broken Hill region. The hot zone is delineated by the lower temperature deposits. The hot zone. The hot zone and polygonization of the Broken Hill type deposits. The ellipticity of the hot zone indicates that compressional forces in an east-west direction distorted the original spatial distribution of the deposit. The east-west compression, as indicated by the blue arrows, and the north-south extension, as indicated by the red arrows. There are many publications showing the east-west compression for the central part of Australia over long periods of time. The red circle shows the east-west compression, which has had considerable impact on the Broken Hill deposit. The complicated geology in the Broken Hill region. That complication extends down to distances of kilometers and even meters. It is a prime example of the small-scale complexity in the crust and the large-scale simplicity in the underlying mantle. The following quote is from John Dewey, one of the movers and shakers of the plate tectonics model. Quote, from 1969 to about 1972, the impact of the geological ideas stemming from plate tectonics was muted by the characteristic geological aversion to bold, rational solutions to geological problems. Small-scale complexity commonly retards and obscures our understanding of large-scale simplicity. Thank you. References.